In the previous lecture, I showed you how to use a mean comparison table to analyze the relationship between two variables. A mean comparison table is useful when you have a nominal or ordinal level independent variable and an interval or ratio level dependent variable. You place the independent variable categories in the rows, and then you find the mean of the dependent variable for each category of the independent variable and the mean for all of the observations. You should also indicate how many observations fit into each category of the independent variable and how many observations there are overall. For example, imagine you wanted to conduct a study on variations in ideology. In this study, ideology would be your dependent variable. Imagine you believe that party identification influences ideology. Party would be your independent variable. You believe that Republicans are more conservative than Democrats are. Party, Republican versus Democrat, influences ideology. To analyze the relationship between party and ideology, you collect data on each party's ideology using information from their party platforms, which indicate their positions on different issues. Negative values indicate a party is more liberal, and positive values indicate a party is more conservative. You place the party categories, the independent variable, in the rows, Democrat, Republican, and in the next column you place the mean of the ideology score for each category of the independent variable. Democrats had a mean ideological score of negative 9.75, and there were 23 observations for Democrats. Republicans had a mean ideological score of 12.06, and there were 23 observations for Republicans. The overall mean for all observations for Democrats and Republicans was 1.16, and there were 46 observations overall. In order to assess whether the independent variable had an effect on the dependent variable, you compare the means of the dependent variable across the categories of the independent variable. You also compare the mean of the dependent variable for each category of the independent variable to the overall mean of the dependent variable in the total row. So applying this to our example, the mean for Republicans was 12.06, which is much greater than the mean for Democrats, negative 9.75. The mean for Republicans was 12.06, which was much greater than the overall mean, 1.16. The mean for Democrats, negative 9.75, was much less than the overall mean of 1.16. Based on this information, it does appear that Republicans are more conservative than Democrats are. Even though the mean comparison table indicates that there is a difference in the means of the ideological positions of Democrats and Republicans, is the difference in means and the difference in the mean of the dependent variable for each category of the independent variable large enough to indicate that the independent variable really does have an impact on the dependent variable? We will likely always see minor differences in the mean of the dependent variable between categories even when there is no real causal relationship. We need to determine if the differences we observe are large enough and consistent enough to confidently conclude that the independent variable has an impact on the dependent variable. To do this, we can use a difference of means test. A difference of means test helps us determine if the difference in means of the dependent variable between the categories of the independent variable are positive, negative, or indistinguishable from zero. It also allows us to confidently conclude that the effect of the independent variable on the dependent variable is large and consistent enough to conclude that the independent variable actually does have a statistical impact on the dependent variable. Note that this test is useful when we have a nominal or ordinal level independent variable with two categories and an interval or ratio level dependent variable. In the next part of the lecture, I will take you through the steps of conducting a difference of means test. Imagine you wanted to conduct a study on variations in ideology. In this study, ideology will be your dependent variable. Imagine you believe that party identification influences ideology. Party would be your independent variable. You believe that Republicans are more conservative than Democrats are. Party, Republican versus Democrats, influences ideology. Another way to state this hypothesis is that there's a difference in the mean ideological positions of Republicans and Democrats. To analyze the relationship between party and ideology, you collect data on each party's ideology using information from their party platforms, which indicate their position on different issues. Negative values indicate a party is more liberal, and positive values indicate a party is more conservative. You could use a difference of means test to determine whether Republicans and Democrats have different ideological scores based on this data. Whenever we want to determine whether there is a difference in the mean of the dependent variable for two different categories of the independent variable, and use a difference in means test to do that, we begin by writing two hypotheses, a null hypothesis and an alternative hypothesis. The null hypothesis always states that there is no difference between the means of two samples. Samples in this context is just another way to say two different categories of the independent variable. The formal way to write a null hypothesis is to write h subscript 0 colon x subscript 1 bar is equal to x subscript 2 bar, or the mean of sample 1 is equal to the mean of sample 2. Next, you have to write an alternative hypothesis. Your alternative hypothesis should always have a direction. So either it should state the mean of sample 1 is greater than the mean of sample 2, or it should state the mean of sample 1 is less than the mean of sample 2. The formal way to state the alternative hypothesis is to write h subscript 1 colon x subscript 1 bar is greater than or less than x subscript 2 bar. Going back to the original argument from the beginning of this section, let's assume that conservative positions are greater than 0 and liberal positions are less than 0. Our null hypothesis should be the mean ideological value of Republicans is the same as the mean ideological value of Democrats, and our alternative hypothesis would be the mean policy position or the mean ideological value of Republicans is greater than the mean ideological value of Democrats, since conservative positions are greater than liberal positions in the data. The next step is formulating a decision rule. You will choose one of the following statements. Note, as you can see below, that throughout the difference of means test, you're going to be using two different t-values, one you calculate and one from the t-table in your textbook. If the t I calculate is greater than the t-value from table 6.4, the difference is greater than 0. There is a positive difference in means. Otherwise, I do not know if there is a difference in the means of the samples. You should use this template if you think there should be a positive difference in means. If the t I calculate is less than the negative t-value from table 6.4, the difference is less than 0. There is a negative difference in means. Otherwise, I do not know if there's a difference in the means of the samples. You should use this statement if you think there should be a negative difference in means. An easy way to tell whether you should choose the first or second statement is by looking at your alternative hypothesis. If it has a greater than sign, the difference in means should be positive, because when you subtract a smaller number from a larger number, you will get a positive number. In this case, you should pick the first statement, as you expected the t you calculate to be greater than the positive t-value. If the alternative hypothesis has a less than sign, the difference in mean should be negative, because when you subtract a larger number from a smaller number, you get a negative number. In this case, you should pick the second statement, as you expect the t you calculate to be less than the negative t-value. Before we move forward, I want to explain why we are creating these decision rules. The decision rule you create will help you know at the end of the process whether there is a statistically significant difference in the means of the samples. For example, if you think there's a positive difference in means, and the t-value from table 6.4 that you used in your decision rule was 1.684, if the t you calculate is greater than 1.684, then you could say there's a positive difference in means. If the t you calculate is less than 1.684, then you would say that you don't know if there's a difference in means. Alternatively, If you think there's a negative difference in means, and the t-value from table 6.4 that you use in your decision rule was negative 1.684, if the t you calculate is less than negative 1.684, then you could say there's a negative difference in means. If the t you calculate is greater than negative 1.684, then you would say that you don't know if there's a difference in means. Going back to our example, our alternative hypothesis suggested that Republican platforms should be greater than Democratic platforms. Since it is a greater than sign, we expect a positive difference and should choose the first statement. If the t I calculate is greater than the positive t-value from table 6.4, the difference is greater than 0. There is a positive difference in the mean platform positions of Republicans and Democrats. Otherwise, I do not know if there's a difference in the means of the samples. Next, we have to find out what t-value from table 6.4 that we need. Recall that the row you use in this table is based on your degrees of freedom, which is the number of observations minus 1. The number of observations equals both the number of observations from sample 1 plus the number of observations from sample 2. If you cannot find a degrees of freedom row for your degrees of freedom, use the closest lowest value. Next, to find the t-value from this table, you should also use the 0.05 column for a difference of means test in this course. Applying this to our example, we had 46 observations. So 46 minus 1 is 45. Our degrees of freedom row is 45, but there's no 45 row. So I choose row 40 instead because it's the closest lowest row. Next, you use the 0.05 column when you do a difference of means test for this course. The t-value from table 6.4 that is associated with the 40 row and the 0.05 column is 1.684. We insert this t-value into our statement. If the t I calculate is greater than positive 1.684, the difference is greater than 0. There is a positive difference in the mean platform positions of Republicans and Democrats. Otherwise, I do not know if there's a difference in the means of the samples. Please note, if we were using the less than template, you should insert the t-value with a negative sign. It would have said something like, if the t I calculate is less than negative 1.684. Now that we have our decision rule, we can calculate our t-statistic. T equals the mean of sample 1 minus the mean of sample 2, and that value divided by the standard error of the difference. This t-test takes into account how much the means of the two samples differ. It also takes into account the standard deviations of those samples. The means of the two samples have to be far enough away from each other to be considered statistically different. In addition, observations cannot vary too far away from the mean of each sample. If the means of the two samples are different, but observations from each sample vary too much, this leads observations from both samples to overlap, meaning the sample means would not be different from each other. The first step in calculating the t-statistic is finding the mean of both samples. The mean for Republicans was 12.06 and the mean for Democrats was negative 9.75. Next, we calculate the numerator. The numerator is the mean of sample 1 minus the mean of sample 2. Remember to subtract the samples in the right order. Sample 1 was for Republicans and sample 2 was for Democrats. So the Republican platform mean was 12.06 minus the Democratic platform mean, negative 9.75, which is 21.81. So 21.81 is the value of our numerator. Next, we calculate the denominator. Recall that the denominator was the standard error of the difference. The standard error of the difference of the two sample means is calculated as follows. The square root of the sum of the squared standard errors of each sample. Recall from the last lecture that the standard error for a sample is the standard deviation divided by the square root of the number of observations. So applying this equation to our example, the standard error of sample 1 was 2.2 and the standard error of sample 2 was 1.68. The first thing you should do is square each standard error. 2.2 squared is 4.84. 1.68 squared is 2.82. Then you add 4.84 and 2.82 together, which is 7.66. Then you take the square root of 7.66, which is 2.76. 2.76 is your denominator. Now you divide 21.81 divided by 2.76 is 7.9. 7.9 is the t-statistic you calculated. Now you go back to your decision rule and compare the t-value from the decision rule and the one you calculated. We stated that if the t I calculate is greater than positive 1.684, the difference is greater than 0. There's a positive difference in the mean platform positions of Republicans and Democrats. Otherwise, I do not know if there's a difference in the means of the samples. The t-value we calculated was 7.9, which is greater than 1.684. Therefore, there is a positive difference in the means of the platform positions of Republicans and Democrats. Step 5 is making a conclusion. If the difference is different than 0, you add, the null hypothesis stated that there was no difference in means. I reject the null hypothesis. As the alternative hypothesis predicted, there is a positive or negative difference in means, and that difference is significant. Then you add a discussion of the specific effect of the independent variable on the dependent variable. Applying this to our example, we can conclude I can reject the null hypothesis. As the alternative hypothesis predicted, there's a positive difference in means, and the difference is significant. And then you add a discussion such as, Republicans are more conservative than Democrats are. Now imagine that the t you calculated was 1.15, which is not greater than 1.684. Then you could not conclude that there is a difference in the means in the samples. Had the difference not been different than 0, you would add, I fail to reject the null hypothesis. I cannot conclude whether there is a difference in the means of the samples. There is no evidence that the independent variable influences the dependent variable. You simply do not know, and you do not add any more discussion. Next, I'm going to give you a few more examples on interpreting difference of means tests. Imagine we had income as our dependent variable and gender as our independent variable. Our null hypothesis would be the mean incomes of men and women are equal. Our alternative hypothesis could be the mean income of men is higher than the mean income of women. Imagine our decision rule was if the t I calculate is greater than positive 1.646, the difference is greater than 0. There is a positive difference in the mean incomes of men and women. Otherwise, I do not know if there's a difference in the means of the samples. The t we calculated was 12.3. 12.3 is greater than 1.646. Therefore, I can conclude the t-value I calculated is 12.3, which is greater than 1.646. There's a positive difference in the incomes of men and women. The null hypothesis stated there was no difference in means. I reject the null hypothesis. As the alternative hypothesis predicted, there's a positive difference in means, and the difference is significant. Men earn more income than women on average. Next, imagine we had voter turnout as our dependent variable and gender as our independent variable. Our null hypothesis would be the mean voter turnout of men and women are equal. Our alternative hypothesis could be the mean voter turnout of men is higher than the mean voter turnout of women. Imagine our decision rule was if the t I calculate is greater than positive 1.646, the difference is greater than 0. There is a positive difference in the mean turnouts of men and women. Otherwise, I do not know if there's a difference in the means of the samples. The t we calculated was 1.10. 1.10 is not greater than 1.646. Therefore, I can conclude I fail to reject the null hypothesis. I cannot conclude whether there's a difference in the means of the sample. There is no evidence that the independent variable influences a dependent variable. Next, imagine our dependent variable was military spending and our independent variable was institutions, democracy/dictatorship. Our null hypothesis would be the mean of military spending of democracies is equal to the mean military spending of dictatorships. Our alternative hypothesis could be the mean of military spending of democracies is less than the mean military spending of dictatorships. Imagine our decision rule was if the t I calculate is less than negative 1.646, the difference is less than 0. There is a negative difference in the mean military spending in democracies and dictatorships. Otherwise, I do not know if there's a difference in the means of the samples. And the t we calculated was negative 12.3. Negative 12.3 is less than negative 1.646. Therefore, I can conclude the t-value I calculated is negative 12.3, which is less than negative 1.646. There's a negative difference in the mean military spendings of democracies and dictatorships. The null hypothesis stated that there is no difference in means. I reject the null hypothesis. As the alternative hypothesis predicted, there's a negative difference in means and the difference is significant. Democracies spend less on their militaries than dictatorships do. Next, imagine our dependent variable was U.S. military spending and our independent variable was President's Party, Democrat or Republican. Our null hypothesis would be the mean military spending of Democrat and Republican presidents is the same. Our alternative hypothesis could be the mean military spending of presidents who are Democrats is less than the mean military spendings of presidents who are Republicans. Imagine our decision rule was if the t I calculate is less than negative 1.646, the difference is less than 0. There's a negative difference in the mean military spending of Democrat and Republican presidents. Otherwise, I do not know if there's a difference in the means of the samples. And the t we calculated was negative 1.10. Negative 1.10 is not less than negative 1.646. Therefore, I can conclude I fail to reject the null hypothesis. I cannot conclude whether there's a difference in the means of the samples. There is no evidence that the independent variable influences the dependent variable. Throughout this course, we discussed different methods to analyze the relationship between two variables. Here is a metacognition card that summarizes when we should use these different types of methods to analyze the relationship between two variables. If we have nominal or ordinal level independent and dependent variables, and we wanted to use simple statistics to analyze the relationship between these variables, we could use a cross-tabulation table. If we wanted to test if the independent variable has a statistically significant impact on the dependent variable, then we could use a chi-square test. If we have a two-category nominal level independent variable and an interval or ratio level dependent variable, and we wanted to use simple statistics to analyze the relationship between these variables, we could use a mean comparison table. If we wanted to test to see if the independent variable has a statistically significant impact on the dependent variable, then we could use a difference of means test. If we have an ordinal level independent variable and an interval or ratio level dependent variable, and we wanted to use simple statistics to analyze the relationship between these variables, we could use a mean comparison table. If we wanted to test to see if the independent variable has a statistically significant impact on the dependent variable, we could use a difference of means test as long as the independent variable only takes on two categories. In the next two lectures, I will teach you two additional tests you can use to analyze the relationship between two variables: correlation and ordinary least squares regression.